Okay, another guinea pig cross. So we're still using the setup where big B is black and little b is white. And then for hair length, we have big S is short hair and little s means long hair. It bugs me that the big letter goes with the short hair and the small letter goes with the big hair, but we will manage. That's why you write stuff down to avoid screwing up. So if we have those down, what do we have for mom and dad today? Heterozygous for black and short hair. Okay, so mom is heterozygous, big B, little b, big S, little s, that's what double heterozygous looks like, is crossed with a white. White is a recessive trait, so you have to be double recessive to show it. And long hair, which means little s for the dad. By the way, I think I've mentioned this before, but there is no set order for which of these is the mom and which is the dad. I tend to say mom and dad versus dad and mom, and so I tend to put the female first a little bit, but I'm not stuck with that, and you don't have to be either. It truly does not matter which of these you write first or which one goes on which side of the Punnett graph. As far as how their genes are going to mingle, it's completely egalitarian. You can put the order however you like, or follow the order that they give. It's all good. So we need to do a Punnett graph for this, but first we need how many gametes can come out of each of these parents. Here we have maximum variety. This one has hetero for both traits, which means it's going to produce 4 different gametes. We can get, if we FOIL this, the first B with the first S. We can get the outside, far left and far right, big B, little s. Inside we can get little b, big S. And last we can get little b, little s. How about this parent? How many gametes can come out of them? Just one, right? When you're like this, you only have one type of B you can pass on, and you only have one type of S. So when you're homozygous for both traits, it's very simple. You know exactly what your kids are going to get from you. They're going to get the only B that you have, and they're going to get the only S that you have. So if we lay this out as a Punnett graph, we're going to have, it's going to be a 4 by 1. You can write that 4 wide and 1 high, or 4 high and 1 wide. It doesn't really matter. I'll do it like this. So mom, here's mom's 4 different eggs. Little b, big S, and little b, little s. And dad's 1 sperm cell, little b, little s. So what kind of guinea pig offspring can we get here? Big B, little b, big S, little s. Here, big B, little b, little s, little s, little b, big S, little s, and little b, little s, little s. So if you want the genotypes, there they are. If you want the phenotypes, big B is black, and big S is short. Big B here is black, and little s's mean long hair. Little b's give white, and big S, little s is short. And here little b's give white, and little s's give long. So these are all different, right? Yeah, okay, so for phenotype you'd have, just for kicks I'll type one out because I haven't done that in a while. We have 25% black short. We have 25% black long hair. From this one we get 25% white short hair, and from this one 25% white long hair. That would be your phenotype breakdown.